So in this video, we're talking about logarithmic functions. Again, we're starting off with the parent log function, and then we're going to talk about how to transform it to the child log function. Like we did with radical functions and exponential functions, the process is going to be very similar. So hopefully you're starting to see a pattern and see the connections between these different types of families of functions. So the graph of the parent logarithmic function is given by y equals a times log of b of x, where b is the base. This parent function for the logs is always going to pass through the point a comma 0, and the y-axis is an asymptote of the graph. Now remember, like what we talked about in the last video, an asymptote is just an imaginary line that the graph gets really, really close to, but never, ever, no matter what, it's never going to touch. The graph of the child log function is given by y equals a times the log base b of the quantity x minus h plus k. And to graph it, like we've done in the past, we're just going to graph the parent function, in this case for logs, and then we're going to shift that graph h units horizontally and k units vertically. In example 23, I have the child function, and I've already graphed it for you. We want to state the domain and range. Before we do that, though, we're going to go a little bit above and beyond, talk about what a is, talk about what h is, and talk about what k is. Now, I do not have the parent function graphed here, so we're not really going to do too much comparison between the parent-child function like we have in the previous videos. Here, based on our rule for the child function, a is going to be positive 1. H is going to be 0 because we just have an x here. And then k is going to be negative 1. Well, remember our parent function, if it was graphed, it's not graphed here, but if it was graphed, it always passes through the point a comma 0. So our parent function has to pass through the point 1 comma 0, 1 comma 0, which would be right here. And then what we do is, to get the child function, we're going to just shift down since there's no horizontal shift. Shifting down, we get right here on our child function. That's exactly what's supposed to happen. Okay, so now that we've graphed that, we also know that for the original parent function, the y-axis was a asymptote. So that's kind of like the force field. This graph is going to get really close to that line. And again, since there's no horizontal shift, this asymptote is going to stay in the exact same place. So we have a horizontal asymptote. X equals 0. And you might see the connection between the horizontal shift and where the asymptote lives. Since there's no horizontal shift, our asymptote is still at the x equals 0. X equals 0 is just a fancy name for the y-axis. If there was a horizontal shift, say negative 5, then our horizontal asymptote would be also x equals negative 5. Anytime you have x equals, it's going to be a vertical line. Again, an asymptote is just a line that the graph is going to get close to but never touch. And that's going to affect our domain and range. Let's go ahead and talk about our domain and range now. I want to start off with the domain. Well, we can see that we have a horizontal asymptote at x equals 0. So what that means is there is, when I'm talking about domain, I'm looking at how does the graph behave as it goes to the right and how does the graph behave as it goes to the left. Well, since we have this horizontal asymptote of x equals 0, we can't get past x equals 0. We have this asymptote in the way. So the graph is going to get really close to this wall, but it's never going to touch it. So we know the domain is going to be x greater than 0. Again, it's not greater than or equal to 0 because it never touches this asymptote. Now let's look at the range. When we talk about the range, remember we're looking at how does the graph behave as we go up and down with our y values. So we see that the child function goes all the way up this wall as far as it wants to go, and it goes down, granted very gradually, but it keeps going down, 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 down as far as it wants to go with no restriction at all, so the range is all real numbers. Okay. And that's it for example 23. Let's go on. In example 23, we have the graph of a child function graphed again. We want to, again, state the domain and range. So first off, what I want to do is figure out what my a is, what my h is, and what my k is. Based on the pattern that we saw on the previous page, we know a is 1, h is now negative 2, and k is 0. There's no vertical shift. We know that the parent function, if it was graphed, it's not graphed here on this picture, but the parent function always goes from point a comma 0. So one point on the parent function that we know for sure would be 1, 0. And to get there, for this particular child function, we're going to do a horizontal shift of -2. That means we're going to the left. Okay, and we do end up on our child function exactly the way we're supposed to. There's no vertical shift, so that's fine. Also, for the parent function, we know that there was an asymptote on the y-axis, so the parent function would never touch the y-axis. However, now that we've shifted, a horizontal shift of -2, that asymptote is now shifted as well. Okay, so the asymptote for log functions follows the horizontal shift. So now we have an asymptote at x equals -2. Again, the asymptote is the same as your horizontal shift, it's just x equals because it's a vertical line. Now that we know where our asymptote is, we're set to do our domain and range for this child function. I'm going to start off with the domain again. When we're talking about domain, we're looking at how does the graph behave as we go to the left and right along the x-axis. Well, as we go to the right, we see that the graph goes as far as we want to, so no restrictions that way. But as we start going to the left, we hit this asymptote. The graph is never going to cross that asymptote, it's going to get really close. So it's getting as close to -2 as it can, but never quite hitting -2. So that means that x has to be greater than -2. Again, it's not greater than or equal to -2 because asymptote means it never actually touches that value. Now let's look at the range. When we're talking about the range of a graph, we're looking at how does it behave on the y value. So how does it behave as it's going up and how does it behave going down? Well, very clearly going down, there's no restriction that falls through the floor pretty fast. And as we go up the y-axis, we see that very gradually it's increasing, but there's no restriction. It just goes slow. It's alright that it goes slow, no big deal. So the range is all real numbers. So now we have AHK, we know where our asymptote is, and we know the rules for our domain and range for this particular child function. That's it for log functions. If you have any questions, please let me know.